everybody, and welcome to Sparring Partners. I am Monica Paolini from Sense of Healy, and today I have the pleasure of talking once more, since we have a bunch of this already, with Per Kangru at VIAVI Solutions. Per, thanks for being with us today.
Thank you very much. It's always a great pleasure being here. So thanks a lot for having me again.
Yes, and we've been talking about a lot of things in the past, and again, always a great discussion. And today we are moving to a new topic that we have not talked much about before, which is monetization. And monetization is a topic that people talk about all the time, and yet it just feels like it's kind of an unresolved issue in wireless, in telecoms, I would say, actually. And so what we're going to talk about today is to think of a way to move forward. Because a lot of the time the discussion has been, we keep trying, we've been, like for at least a decade, if not more, to go the same way. And it has not worked all that well, right? So the question is that, what is that we can do better? So, but before we get there, I would like to for you to introduce yourself. Tell us a little bit about what you do at VIAVI, what's your background, and then we'll get started.
Absolutely. So I'm having the pleasure of working on a really diverse set of technologies and areas, and really looking to see how do we find the future of telecom, and what does that entail? What challenges does it entail? And then from that, figuring out what should VIAVI do in these areas. So for the last couple of years, I spent a lot of time on the move towards zero-touch service management. So basically, how do you get to a lights out and sort of dark knock and all of those things? That obviously includes really an evolution to a digitization of the business. And as you digitize the business, you can start looking at a lot of new business model and new business models and ways to make money. So as a byproduct of looking at how we automate operators, we got a lot of good ideas of what to do next through that journey. And I've come into this from a really, I would say, rather strong technology background, and I've been spending a better part of the last 20 years figuring out how to first make sure 3G works. And I started working on that from a simulation background, trying to figure out how we can simulate IUB interfaces into RNCs and to do functional load testing on that. I did a short stint in a slightly too simple technology with MPLS and MPLS conformance testing and things like that. It was a little bit too easy. So I went back to real complex stuff, which was really analysis of telecom networks and really stitching things together end to end. And that took me through the journey of having to make 4G work. So I worked with industry on that side. And we really brought together as well, not only 4G, but the whole evolution of the smartphones. So we spent a fair bit of time together with the smartphone vendors to build up how you can test and evaluate that all of the smartphone infrastructures work properly into the networks, that they have the right mobility and the right capabilities, and that you can really get the right performance out of them. So that was really interesting adventure. And from that, it was natural to start looking at how do you now manage these networks, how do you take care of that they actually operate well. And when you then start looking at that and trying to figure out how do you take that to automation, you really get to an interesting challenge. And I think we've spoken about this before around how you can deploy AI and how you can use those things. And it's really around as well a change management process. And obviously businesses and helping to make more money is obviously as well a change management topic. So I could say that I'm more and more evolved from what I would say hardcore technology into more and more of understanding of how to drive certain change and outcomes of that change.
Yeah, and I guess that, as the network become more complex, there is much more to manage, because when you had a voice-only network, well, there's just so much you can do, because there's just so much, so many things you can change. Now we have a lot of flexibility, and so the network, far from being a dumb pipe, it's a really complex kind of thing. And so and there are so many parts to it and so many ways to manage it and to use it.
Yes,
as long as you know how to do it. That is actually quite interesting.
Yes, but
Mm.
let's just first start with something around 2G and voice. There's actually an
Mhm.
interesting learning from that, and this one has actually been haunting me in the industry for, I mean, more than 20 years. So if you go back to 2G, and we remember the days of that, and what happened when it got a congested cell in GSM? Well, suddenly the voice quality turned terrible because someone actually decided to do a half rate. Someone decided to take that time slot, slice it in two, and only give you half of the resource, and suddenly your voice quality was really bad. But the question was that better than no call? So if the choice was you can make a call but not perfect voice quality, or you would be able to make no call, what would you as a user preferred? Because you were really at the point where you had no more capacity, and it was really those two choices. Interesting enough, if you're then starting looking at that concept, now you're offering a service but with lower quality. Should the user have expected to pay a lower cost for that voice call? Well, actually, there was no flexible billing. And then after that, there evolved a lot of discussions around, if I actually deteriorate the quality of the user, should I actually give them lower monthly bill or not? And when you then start thinking about monetization, which we will come into, the whole question about billing and the question of charging becomes interesting. And half rate, well, customers didn't like it for the quality of experience, but no one got a lower bill, but just because they got half rate for whatever, 50 minutes of phone calls during a month. That's
Yeah.
an interesting thing to think about when you then start looking at what should people charge for, what should they pay for, and what are they not willing to pay for.
Yeah, but in order to do that, and I guess that, with voice, maybe it was an easy decision. You just cut cut the quality. But
Yeah.
sometimes if you have a bad user experience, it's kind of hard
Mhm.
to know how bad it is because it depends on what you do. So it's not that trivial. So you need to have the charging capabilities. You need to have the ability to actually know there is something wrong, that you should be charging more or less, whatever the case might be. So it's actually not trivial because you need to know what's going on and what is that the
Well,
user
yes.
sees, right?
Yes, but then we can as well see that there are certain of these and satellite providers that's coming into the market. And as we know with satellites, obviously you have a limited capacity per sort of area of the world. And when you're then in their cases, they actually know how many subscribers they can serve there. But then they have a contract where the user can actually cancel on a month-by-month basis. But that means as well that they can raise prices on a month-by-month basis. So as they are basically loading up and becoming basically full in one of these sectors, they raise the prices. And then they will obviously know that there will always be one customer that churns away. So they're always open for one more customer, but they get everyone to pay more. If you discuss that model with the telecom operators, they will scream because they have no ability to do that similar things with their customers, which really means that if you look at it from a telecom point of view, it's really, really hard to raise the general ARPU of the users, and trying those type of things that, I mean, it doesn't matter whether it's Starlink or any one of the other ones is basically playing, that becomes extremely difficult for mobile operators. So ARPU increases from, how should I put it, playing a sort of pricing game is very challenging. But for new entrants like the satellite operators, they do it from the beginning. And
Yeah.
obviously, someone's getting unhappy and churning away, but majority of the people starts paying more.
Yeah, and it depends, because obviously it depends on what are the alternatives, and if you have subscribers, like in the US, most of the people are on unlimited or nearly unlimited plans. It's kind of hard to charge more if it's already unlimited. How much? What is it you can charge me for?
No,
Um,
exactly.
you
Which
can,
which
but it's
which
not that trivial.
no,
You know.
correct. The only thing that you can in that time can charge for is that, say, well, next month it's not $22, it's actually $30 or actually $50 or $55. And yes, it's still unlimited, but next month it's a different price than it was last month. And as long as you deliver a service that has enough stickiness, people will actually pay for that. And then
Yeah.
someone will churn away, which in the satellite business means that you always have one slot free in the sector, and you can always sell it to someone who's willing to pay that premium price. So anyway, I don't want to dwell on that one too much, but it's an example of how other people who come into a certain offering can play the game, but where telecom operators are completely unable to play the same game. And that's a pretty interesting situation, because then they really have to monetize in some other way.
Absolutely. And this is the kind of thing that I was alluding earlier, is that oftentimes in wireless, what we think about is that monetization means ARPU maximization, increase your ARPU.
Yeah.
And we have not been very successful at that. Let's just put it that way.
Yeah.
And it's not obvious to me that that's going to change next year just because we have AI, APIs, or whatever the latest thing is, which is not to say that they are important and valuable and, whatever. But, I think that what that points is that we need to think of monetization in a fundamentally different way, not extracting a couple of dollars or euros per subscriber, but to have a new approach. And so what I wanted to hear from you is, what is your approach? As I say, you've been working more on the technology side, so you understand the kind of the bits and pieces here. How can those bits and pieces be used for monetization?
Yeah, absolutely. And from high level, you can ultimately think about this in various ways. So first of all, most of the mobile operators really operate in a regulatory framework, which means that there are regulatory aspects on what you're allowed to do and what you're not allowed to do, et cetera, which means that even if it would be very valuable to sell the information that myself is going to a certain pizza place this evening, and I've been going to this pizza place 10 times in a row, that information might be extremely valuable to the competitive pizza places that could give me an offer and try to get my business instead. So due to the privacy laws which are present in most regulatory environments, that information is very, very difficult to legally be able to sell. So actively being able to sell that. But what's possible is that you can put myself and then everyone else in a certain demographics into a bucket, and then you can sell statistical behavior of what we are doing. And this can then be monetized in quite interesting ways. So this is really a first bucket of, I have statistical information about subscribers, how they behave, who they are, and what type of demographics they belong to. And then I can actually find buyers of that data. And those are things where, for example, transportation companies use this because they really want to know who is taking a certain bus route to a certain endpoint from a certain starting point, who is taking a certain subway, and so on and so forth. And this can obviously be used both in sort of capacity planning and network planning for those services, but it can as well then be used in more real-time way if there is an outage. So say that a subway train breaks down. If I now generally know the demographics of the people on this train, I can start knowing how should I actually plan my basic replacement buses that needs to come in and take care of these 2,000 people. Where should I ask these buses to drive? Should I just take arbitrary destinations, or can I in real time actually have an API where I can say that these buses should go to these different endpoints, and then as people flood out of the subway station, they will immediately be directed either through an SMS to their phone saying, if you go in this direction, take that bus, etc. So there's aspects of that where we can do, and then it's just a question of, is there a receiver of this type of data that has a business model where they can actually take this data and use it appropriately to drive their things. Historically, you obviously had things like, if I want to open up a new department store in a certain location, what should be the right location for my demographics? Where should I get the right footfall for my demographics? And those type of analysis can obviously be done based upon the statistically significant data, and then you can figure out where to do those things. So that's an easy one to basically figure out. The problem is that each of these transactions, even if it's very, 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 very valuable to figure out where to place a certain store, it's still just a couple of $1,000s per transaction. And there's not a million new stores being opened up in a country, and therefore it's not going to be a multi-million, multi-billion dollar revenue source for any operator. But it's going to give you, small ticks in the box. So that's one area where we start to see how we get
here. Yeah.
Yeah.
As I say, it's not like this, and I guess none of this, whatever thing we can think of, is going to change dramatically in 6 months. The revenues are going to double. I mean, but there is a lot of incremental stuff. And once you get
Yes.
all the data, you say, well, the location of the store. Sure, but you can see many more use cases once the data is available and we understand how to use it. And
Yeah.
one that you didn't mention, but I think you sort of implicitly assume is the assumption is that the phone is really is the only way to actually track people in an accurate way through time and space, because pretty much everybody has a phone.
Yes.
Or we can assume that.
Yes.
And so, yeah, you can track people in other ways as well. You can have cameras, you can have all sorts of other ways, but they're
Yes.
not as complete
Correct.
in terms of
Correct. And yes.
providing, that is kind of, there's just no equivalent of that.
Correct. And what we've seen historically, and I think all of us have been subject to this, that if you download a free app from an app store, doesn't matter whether it's the Google one or the Apple one, etc., that contains a certain amount of tracking software. And then we've seen in the last period of time in basically both the Android and the iOS versions that we're starting to get more and more control, where the tracking in those apps starts to get more and more basically requiring the user consent and the user opt-in for that. And if you're not opting in for that, well, then at that point they're not able to track you. And that walled garden is actually becoming pretty strict. That means that wealth of information that have been available from a different ecosystem, which is outside of the operators, is getting less and less with lower and lower fidelity and lower volume. And net is that this is now where the operators start to have an opportunity to start to provide this data and actually becoming one of the few parties on the industry that can provide a wholesome visibility on a large percentage of the population. Of course, each operator would never have normally more than 30, maybe 40% market share. So it's never going to be 100% market share of the population from a single operator. But if you look at statistically valid data, you're going to have that. So as long as I'm not looking to track Monica or myself or any other specific individual, which once again would be very, very difficult to do from a legal perspective, the statistical composition of what an operator have generally gives you the validity of the outcomes related to the full population. At least if the operator have somewhere between 20, 22, 25% market share, then you have statistical validity of the results for the whole population.
Yeah, and for some services, you might be okay to allow the operator to know who you are, because that would allow them to give you better guidance as to.
Sure. But
I mean,
that
but
is where
that
you
just
then
has to
start.
be, that's a different kind of service.
Yeah, sure. But that's where we then start to speak about some of the opt-in services. And we can, for example, see what the industry are doing with, for example, the Camara APIs and all of the API initiatives. So there's one there, which is, for example, about the credit card fraud. So as I basically have a credit card, I would basically agree that this credit card company, if I give them my phone number, they would be allowed to check that my phone is relatively close to my where my card is used in the payment terminal, and from that they can actually say with higher probability that it's actually my transaction. So if the card is trying to be used in, say, well, whatever, Barcelona, and I'm still in Sweden, well, it's most probably fraud.
Yeah,
But
not against
if basically my phone instead saying, well, Paris and Barcelona, my card is in Barcelona, and it's actually in the same sort of same district of Barcelona, well, it's much more probable that it's me. So based upon that, there's a fraud minimization use case. Of course, that can be driven from our data, or it can be driven from general network data that's available from the location systems. But fundamentally, it's a matter of me opting in, agreeing for this to be done, and then that network can be used for it. So those are individual services, but in the end of the day, that's once again, it's only going to give you a couple of cents at best on each one of these transactions. So once again, it's not going to be the magic wand that gives you millions of dollars of incremental revenue, but something else. So net is, how do operators really get more money into the bank? And I think that this is where they need a combined thought process. first of all, they have to understand what are the assets they're selling. Sure, they have a brand and a brand value, and that's normally what people say. Well, this brand has a premium value. We can charge more. We can have a little bit higher prices than the other one. Sure, that's accurate, and that's based upon, in many cases, that they do these benchmark surveys and they get basically an award saying best network in country and so on. But beyond that, the fundamental thing is that they sit with capacity. Everyone build out capacity in the radio networks, in the fiber networks, etc. The question now is, how much of that capacity is really used all of the time? And can you actually figure out that you have areas of your network where you have largely unused capacity? Now comes interesting statistics, and it's maybe not true for you and me, Monica, but or the people listening to this, but in general, in the general population, on a daily basis, people actually don't move more than across 7 base stations. So if I now start looking at around these, whatever 10,000 base stations in my network that I have, maybe 3,000 of them have a huge amount of spare capacity. Now I can figure out which are the users that are using around, that is basically using those 3,000 base stations. And if I now have a lot of spare capacity there, can I now offer them some packages that I can get a couple of dollars more for? So I increase the ARPU for that, because I can actually monetize that capacity better with this audience. Obviously, I should not go out and sell that to audiences that generally spend their time in areas where I have no capacity and is always a congested network. I'm not going to sell I'm not going to upsell a campaign to those, but for the other people, I can do that. I can find who those people are and I can target them with an offer.
Yeah, and you can target also whatever company or whatever provider sells them services or offers services. Because, yeah, if you look at it, and this has been, we know that forever, is that the utilization is like, this curve where you have very few base stations that have huge amount of traffic, and a lot of them that you have them basically for coverage, which you need to have, but they're not particularly, so, when you look at capacity, it's like not all bits are created equal. There is a lot of different, and I guess you can say the same for latency and all of that.
Yeah.
So that's a huge, there's a lot of value that operators leave on the table, basically, because they basically charge for every bit the same way.
Yes. So the key first to think about from the operator economics is that you have to build your network for what peak capacity you need to be able to deliver at each point. But your revenue is only associated to the average capacity that is used in that area. So this game is then about, can I raise the average? And if I can raise the average, that's going to give me more revenue. I already have the investment done for the peak, but I want to basically minimize the ratio between peak to average. And if I can do that, there's a huge amount of extra money on the table for me. And the question is, how do you find out where you have spare capacity? Do you find it out so that certain cells you obviously have, as you said before, a general build them for coverage. Well, there I can always sell extra capacity to anyone that might be there. If it's just in the middle of a farm, well, it might be difficult to add more people there, and maybe the sheep and the cows and so on is not going to be the best users, because we really haven't seen IoT take off, so we're maybe not going to monetize that hard and get a ton of extra revenue. But maybe there are other areas where you can identify and say that, hey, here in this area, I actually have a spare capacity during these hours of the day. Can I now construct some offer around this? Maybe there's an ability to look at it and say, well, in this area, I have spare capacity during this period of time, which happens to coincide with, where families might have kids who just came home from school. Maybe I should just have a Disney Plus is free from a capacity point of view between 3 o'clock in the afternoon until 5 in the afternoon. Well, families might like that because the kid's gonna love it. So, but in the same time, I could then say, well, on parental control, I'm actually not going to allow Disney Plus on my network from that device after 5 o'clock, because then the kid should be doing other things. So when you start thinking about the composition of these services, you can start offering some interesting things. But once again, you have to do that smart, because obviously you should not offer that so the kid sits at the train station where you have maximum capacity utilization and is really bad, and you offer him free Disney Plus there. know what you have, know where you want to sell it, to whom you want to sell it to, who's basically in those areas, and then do the smart offerings. And this obviously takes you to needing to know this and how you get there.
Exactly. That's my next question. Is like, okay, got the point, but do operators have that kind of knowledge? I mean, really fine-grained knowledge about
Yes,
where is that they not only did they have the spare capacity, but they can actually predict it, because in order to sell it, you need to know ahead of time you have it.
yes, yes,
Because
yes.
after
Because
the fact,
obviously,
it's so you need to know you have it. You need to know how to package it. I mean,
yes,
how to present it and how
yep,
to charge, and who
absolutely.
you charge it to. Is it the end user or is it the app provider?
Yes, exactly. So the first thing is that if you ask yourself, do the operators have it? Well, if they have a existing network management system that generally works out of existing FM and PM feeds, well, the answer is the most pro don't have it. Because the PM data tells you average utilization or utilization at each point in time, etc., but doesn't tell you who the users are in the cell. So if you start talking about, do I have single subscriber visibility to my network? Would I be able to say who are the users who've been in certain areas? Would I be able to do that mapping? Well, if you have those type of tools, which, well, if you work with VIAVI, you may have them. You may have that visibility, both on the geo side and the RON side, and then as well on the core network side. So based upon that, we would be able to, I mean, inform people about these outcomes. We would be able to generate, I mean, the appropriate data out from what are the parts of the network where you have spare capacity and you would be able to monetize it, what would be the demographics available there, and who would be the specific users, so that a marketing team would then be able to take that and action it, not only in theory, but specifically. And then it's just up to them to say, how do they communicate with that user group? Do they send targeted offers over text message? Do they have an app installed for the operator where they can target with dedicated offers from that? Or do they put a billboard in a specific area of the town and basically through the billboard advert to specific localized services? I mean, that's obviously just up to their execution strategy on how they do it. The next piece of that is then, as you said, certain of these things are very temporal in nature. Well, I mean, the capacity in the network is really, it's here and now, use it today or lose it. Well, it's not really only today, but it's really in a fraction of time, I have the spare capacity. Next minute, there might be a bus coming here full of teenagers doing TikTok, and well, now the capacity is suddenly no longer there. So as you say, I need to be able to know both from what is it now, what is predicted in the next period of time, and then from that build a strategy for what I do. So the visibility of available assets, available resources, for whom I would be able to then monetize it for, that becomes really, really important. But now we've predominantly spoken about what I would call the B2C area. So business consumer, trying to generate offers for those. There's interesting aspects here, and but where, if you remember in the beginning, I said that I more and more start working on the sort of change management aspects. So what's interesting now to think about is that who are the big players spending big money, and where would we be able to see that we are able to generate significant value for someone that they're willing to pay for? Well, there's a lot of enterprises that have workload costs today in the cloud and in data centers and other things. Are we now able to offer them something interesting? And this is where it comes to change management. So if they just continue as they do now today, you would need to offer them something that is potentially not temporal in nature or geospatial in nature, so it's only on one location at one point in time, but you would need to offer a blanket service across the network, etc. But if I instead can come up with a workload scheduler where I can basically say, well, I may be a car company and maybe I need to update 1 million cars with a firmware update. From my point of view as a car company, I need to have it done within the next couple of days. Okay, now the operator can tell me predictively when will each of these 1 million cars be in a location where it will be spare capacity available. So I can actually do that download without wasting or rather causing congestion in the network. Well, if I then schedule my workload at that point in time, when my car is in that area, maybe the operator is willing to sell me that capacity for basically a lower cost. And if I'm willing to do that, and if I'm willing to buy it, I adjust my workload to do this. Maybe it's a better deal for everyone involved. And when I'm thinking about these type of things, there are actually examples of this and where people are adjusting their workloads in this. If you go to an AWS, for example, and it's the same for every other hyperscaler, there is what's called spot pricing. So they're basically saying these compute resources are available right now. I don't know for how long, and I don't necessarily know what I'm going to charge you next hour. But if you start using them now, they're available at a very, very low cost. So that means that people have started adjusting their compute workloads when there's availability of low cost compute. I don't know if it's going to be available all of the time. I don't know for how long, but if it's available now, I'll use it now. So if I now can start thinking about connectivity, as in this case, and I start scheduling my workloads, this can become quite interesting. But it's all about being able to add flexibility to the workloads so I can actually use this temporarily available resource, and for the operators to then agree, I'm actually willing to sell it to you at a lower cost, because I can then monetize and sweat my assets harder.
Yeah, and this is really interesting because it's kind of like the other extreme of what we were talking about before. So you charge more when, I mean, it's like a demand and supply. When supply is more limited, whatever you're selling has bigger value. Otherwise, it has lower value. And but the thing is that if you can sell, like, you know, the car software upgrades, you can do them, say, overnight, when supposedly you have less traffic. It's also valuable because it reduces the load at congestion time, at peak time. So there's that kind of like, it's not a revenue advantage, but it's still an advantage to the network, because actually you can sell more, or you can get, so basically there is in sort of an implicit advantage that you cannot quantify in an easy way, but there is an advantage. And you sell something that otherwise you just sit there. And this is again something that if you see the network usage is actually even during peak time is very, it fluctuates a lot. And the difference through time, it's huge. Naturally, because as humans, we do things that we all do the same thing at the same time in the same place. We're kind of boring that way, right?
Yeah. And this is exactly what you spoke about before, that if you can close the gap between the peak and the average utilization, then you're going to start having a much, much better financial situation. So in this case, what we're speaking about is that, as you're saying, I'm going to take what might be otherwise a peak load, where this car is going to download the software. I'm going to move it to another place, which is going to reduce the peak, increase the average, and off we go. Everyone's happy. But it takes quite a mindset change at the operator. Instead of trying to do as they've been doing in the last number of years, which is always to figure out who is willing to pay more. Who is willing to pay more for a guaranteed service, or who's willing to pay more for premium service? My assumption here is that, and what's been proven so far is that very, very few people are willing to pay for premium service today. And based upon that, I think that any of those use cases or value propositions is fundamentally not going to deliver more, I mean, more business, especially if I'm a enterprise and I first have to pay money, development resources and so on, to integrate to someone's APIs. And after that, in order to use this API, I actually have to pay a premium. Well, that's something that doesn't really excite a lot of people in the application space. And the other thing to consider is that you can almost never build an application expecting that the user is always going to be on a mobile network, because most users is using Wi-Fi at some point during the day. And when you then start looking at it, do you build your application requiring that the user is on a 5G or 4G network with certain guaranteed quality service parameters on it? Or do you build an application that works regardless? Well, most of the companies have concluded that it's much better business for them to build it so it works regardless. And that's where it comes in, that if I'm now in a position when the user is out and about in the mobile space, I can actually give you something that is lower cost. That is where it makes sense for everyone involved to actually use that. So
and I guess again, it's a different way to look at it, because as a subscriber, individual subscriber, I might not be willing to pay $1, a euro more for something right now because they say, well, it's not worth it.
Yep.
However, like for instance, for mobile payments, you
Yep.
don't need that much, but you want to have a reliable connection to get the payment to go through, and you know that people are very flimsy. So if I cannot make a payment, I just don't buy it, whatever
Yep.
the thing is. So it might be worth for whoever is doing the mobile payment to pay more to make sure that my connection is reliable, it's working, there is no glitch. So it's a different way because then you would be charging, especially if I use things like APIs, the service provider or the app developer, so somebody else, but not the end subscriber. It wouldn't be me or you paying for it. It would be whoever is providing us the service.
Yeah. So
Or
this is, yeah, this what you're just describing now is what a lot of people fundamentally have been discussing and wanting to be the case. But if you look at, for example, the point of sale payment terminals, sure, they do have a GPRS connection, most of them, or a 3G connection, but in many cases they can as well operate on Wi-Fi. So
yeah.
that restaurant or whatever it is, they will have an internet connection, they will have a Wi-Fi, and then the point of sale terminal operates on that together with whatever cellular technology as well. So in that case, convincing them to pay more for the
It
cellular
would work.
connectivity is not necessarily going to work. So it's one of those where theoretically it works, but the unfortunate thing is that there's in many cases a very, very well good enough Wi-Fi. And
Yeah, I was thinking of a situation where you do mobile payment, not in that way. I mean, like mobile, like through the mobile network without POS, or something
yeah,
to have an
sure.
online transaction,
No, absolutely. So I mean,
not
those,
mediated by anything local. So that would be
yes.
a different use case.
Yes, correct. And then it goes down to how many of the subscribers will actually transition over to those services. Will it be a viable enough business? But what we've been discussing here is really there's small pockets of money in many of these things. The question is, are you willing as an operator to bet on any one of these? And are you willing to bet the investment to build that service, test it out, get a bunch of users on it, and then see did it become a good or bad basic business outcome? But let me just for a moment take a slightly different view on this, because now we've been speaking about trying to figure out a business case for selling data around subscribers to someone in some way, or making it better for individual subscribers, individual apps. There's a different dimension as well, which is actually right now becoming quite interesting. So there's data in the network that can be used to describe various events happening around us. And one of these things, which now becomes quite interesting, at least in certain parts of the world, which is bordering into, for example, Russia, is that there's been a surprising amount of accidents where fiber cables have been broken by ships dropping anchors and just happening to tow the anchor across a fiber optical link, and it's just by accident. And obviously has nothing to do with anyone wanting to break those cables by intention. But if we now have that fiber optical cable, we can actually use what's called an OTDR as a sensor on that fiber. Historically, that's been used to detect when this breaks and find the location of the fault, which is, I mean, obviously very useful to fix it. But we would prefer that we don't have to break it before we can detect it. So what we're able to do now is to do basically what's called fiber sensing. So fiber sensing can then detect sound and vibrations close to the fiber. So based upon this, we are able to detect that, for example, a ship is coming with an anchor and is coming closer to the fiber. And as you may know, in the seas around Sweden and the Baltics and the Finland, etc., right now you have NATO ships patrolling. And if we're only able to tell them after the fact that now a cable is broken, well, they can only go out to police that ship, and we've seen how they've done various raids on those. But we could as well be able to tell them very proactively that, hey, now this ship has dropped its anchor and it's coming closer to this cable. You have half an hour to take care of this. then at that point, that becomes a pretty interesting value, which has a very high dollar value associated to the alternative cost of fixing this. Because obviously sending out a ship to fix a subsea cable is not cheap. And if we now can deter that, that's going to be interesting. So we can now start using a number of these infrastructures to extract data that can be used to, I mean, inform other parties in the world around interesting things. We can use the same technique to do perimeter watching around important objects. And there's fascinating demonstrations where you can actually see how a car is driving down a road, how the car is stopping, and how the man goes out with a shovel and start digging. And all of these objects and things can be detected, and you can clearly see these things. And obviously we're using a combination of then this sound detection plus then clever AI to detect these type of objects and events. So here we have how we can use data which is coming from and around the infrastructure to actually start monetizing it. When we start talking about monetization, one of the aspects is obviously making sure that we protect the infrastructure. But in this cases, we are as well monetizing it in means of that this data is valuable and we can start providing it to outside world for it. And you can obviously use it for many other use cases in smart city that are much less severe than that a attacker is trying to sabotage a fiber cable in the subsea.
But I guess it's the same logic that, again, it's not going to change the overall economics of the sector, but there is so many potential use cases because it's like with sensing. You basically use the infrastructure that is there already. You don't have to spend any more money on the infrastructure. You use the infrastructure to do something else that it was not
Yes.
designed or deployed for.
Yes,
So
correct.
the incremental cost is next to zero or very low.
Yep.
But you know, whatever revenue you can get is kind of gravy on top. I mean, because it doesn't cost you much. I mean, okay, you have to do some investment. Yes, there is little, but it's not like building an infrastructure to do that.
Correct. And that actually takes me to different things when you say building an infrastructure. So interesting enough is that I think we all know that operators have decommissioned infrastructure over the last number of years. So say that an operator, I mean, legacy operator had a lot of PSTN network back in the days. Well, that copper is being dismantled. Obviously, all of that infrastructure was located in sites, in many cases pretty close to the end users. So if you now start speaking about this, well, the operators are getting free space where they often had very good cooling. They often had very good power, and it's generally quite secure infrastructure facilities. Well, this is an asset they have. Can they now monetize this? Well, if you have a good inventory, which can now look at what is my available space, my available power, my available cooling, and I can start mapping this against interesting services that I could offer. And I think we've seen, not only recently, I think it was just the other week here that one of our big operators in the US went out with a strategy speaking about how they will put a lot of these hyperscaler edge nodes very close to the user. They will be able to offer those as locations to run AI workloads. Well, we know that AI workload means I will need a fair bit of power, and I generally need cooling when I have a fair bit of power. Well, here's a golden use case. If I now get a question, can I place 10,000 of these edge units in all around my country? Well, if I now can go through my inventory and effectively locate, well, it's going to be here, here, and here, and I can now automatically, as I have now a digitized business, create the work orders to start shipping these units out. I start creating the work orders, how these going to connect it in. I start creating the work orders, how the network connectivity is going to be mapped out here. And then once these things are connected up, I can then automatically validate that these things are now operating and coming in. Now I have a digitized business on how to monetize that spare capacity in my data center, in my edge data center, which is very sought after and a very, very interesting asset for everyone who want to get close to the user, low latency, high capacity, well, the relevant capacity, close to the user with the flexibility needed in this case for AI workloads, etc. So
Yeah, and
that's another
really
one.
valuable. Yeah, it's really valuable because when I'm sure you've seen them all the time, like in very downtown central locations that will be prohibitively expensive to get now
Yeah,
if you are a hyperscaler and,
yeah,
you just can't do, and well, in a lot of places, just there is no room. You just
correct,
don't.
correct, correct.
Everything is built, but
Yes,
that infrastructure has been there forever. Well,
yeah,
relatively speaking. And so it, as you say, it's extremely valuable.
yes. But the thing is, it's only extremely valuable if you can monetize it. If you
Yeah,
don't
yeah,
have a digitized inventory of this, and you have to send someone to site figuring out, can I rack this up? Do I have enough space?
yeah.
Is my power enough? Is my cooling enough? Well, that may take you weeks. Well, during that period of time, someone else have sold it instead because they're better and more agile in actually delivering that capacity to that customer. So
Yeah.
what you're needing to deal with here is really to have the business agility to answer these questions. And if someone wants to place 10,000 servers across the country, of course, they're not going to send 10,000 letters on paper. Instead, you want to do that business through an API, and you want to ask 10,000 queries. Can I place it in these locations? What will it cost? And can I do
Yeah.
it? And once you answer back saying yes, you want to have that in a digitized workflow going through your business processes. The
Now,
more people that needs to touch any of that, I mean, the less money you will make.
now you have many different ideas in different directions, and it seems like all of them are kind of like require using your existing infrastructure. You're not advocating let's build the whole thing new. It's just to understand better what you have and make better decision and make money out of what you already have. So how has VIAVI here help the operators do that?
So this is really interesting question. So historically, we've been very focused on the radio access network, and a lot of people use our geolocation solution for that. And that is a great data source. And we've seen many customers take our data and then do a number of these use cases. Doesn't matter whether it's a predictive quality of experience and predictive quality of service, which has been demonstrated by a number of our operated customers in events like Mobile World Congress and other things for various interesting use cases, or where they take it, for example, as we discussed with the transportation and mobility use cases, and basically selling it to railway companies and other things like that. So that's where we've historically provided a lot of great data, but we haven't necessarily helped them actually achieve the outcomes. So recently, and what's been part of my role is to see how do we get closer to that. And the key of that is that, well, first of all, we need to have inventory. We need to be able to know what's in the network. Then we need to know how it is utilized. Once we know what is there, how it is utilized, and we can start using, it's not going to be the AI, but machine learning. Can start using machine learning to predict what's going to be the capacity utilization at every segment of the network. If I can predict what it's going to be, I can obviously understand what is left, what's the spare capacity. And now I can start offering some interesting visibility, which can start to be utilized. Next question of that is obviously then going to be, okay, how do I know what subscribers are there? Well, I can get that either from the geo system, or I can get that from a core network monitoring solution. So now I can start overlaying availability of resource together with whom is using it. So I get subscriber-centric insights on that. And then it really goes down to how can I start actioning this? Well, that's where you start to have an automation framework where you can then really start saying, well, when I meet these conditions, make this decision and basically output these things. And whether that are simple things like, well, take this output and send it in a Slack channel where the marketing team is operating and they maybe have a marketing automation robot, or whether it's in integrating it using TM Forum APIs up into ServiceNow workflow, where you may have a business process implemented, or whether it is just as simple as, well, I'm just going to compose a document with all of these recommendations, and I'm going to send it by email. I mean, we don't have an opinion about how people do it. We just know that the more API integrations you do, the more likely it is that you're going to get a digitized business process that actually going to work seamless over a long time. Where you involve human in that process to take an email or take a document or whatever, it becomes a slower process. So think about it this way: data availability, write APIs into that, either a query response API or a exposure API where you can expose the availability, and then making sure that it works. If this is in a hyperscaler environment where we use that framework and platform to make the exposure, that's perfectly okay. If this is a private data center where someone operates it completely in walled garden because that is what their previous environment is, I mean, no problem with that.
Now, let me ask you the follow-up question though, because this is
Yeah.
really crucial that you're able to predict and
Yeah.
know what the prediction is with respect to a place and time. So there
Yeah.
is prediction, so it's it's time
Yeah.
and location and the sensitivity here. So what's
Yeah.
the sensitivity? How early can you predict, or do you need to predict how accurate in space you are? And
Space and time. Space and time.
yeah, it's space and time, yeah, and not just in time, but ahead of time, because you need to predict.
Sure,
Yeah,
sure. I mean, it's useless that I say I could have predicted what happened 5 minutes ago.
could have told you.
Yeah, I
Yeah,
could have
that
told you,
doesn't
but
help.
it's much more interesting if I can tell you something with high probability in advance. And in this case, what's important is to figure out what is actionable for you. So
Yeah,
it's not actionable for you if I'm telling you that maybe there is this capacity, limited capacity available 24 hours from now, because that limited capacity might just be too dangerous to sell. But if I instead, with high predictability, can say there's going to be a fair bit of capacity available here, then at that point it is actually meaningful to sell it. So one has to think about, where do you have an error margin, because all of these predictions are going to have some sort of error margin on them, and overall probability that you're right. So what you're getting to is that you need to get to areas where you have a actionable accuracy, and where the resulting outcome is then something that you can actionably sell. So those two things needs to be true at the same time, which means that a lot of these possible error cases where you're maybe right but maybe not actually become a very limited area, because it's low actionability anyway, and the risk is too high. So it means that you get to a very, very big space where you have enough available capacity, and even if your rate of error is maybe 10%, that actually doesn't matter, because your actionability doesn't go down. So what you're ending up with is that you have an actionable space where you will know that even if I'm having some level of error margin, you're still within good space. But in the areas where it's really tricky, well, your actionability is generally very low, which means that you don't really have to deal with it.
It's actually, yes, and actually I've never thought about, but actually it's really complex because it depends also on the services you're trying to sell. So let's say that I am 100% sure that I
Yes.
have all this extra capacity for like 5 seconds. It
Yeah.
might still be useless,
Yes.
even because it's not long enough for whatever service I would
Correct.
be. So, but there is a lot of value to know that everything is going to be available 24 hours from now, because there might be a service that needs to have that kind of, you need to plan for it.
Yeah.
Some service
Or
so it really is like it's really like it depends on what your availability is, what your services are, where you are, what is the likelihood of, I mean, the error margin. So it's really a complex. So you can provide the input, but obviously then it's up to the operator to decide how to use that data for
yeah.
their own.
So let's give an example. So there's a football stadium. 80% of the time, I have a huge amount of spare capacity because no one is there.
And that you know for sure, pretty much.
Yeah, because I have no
Because you know the
phones.
games, yeah.
Yes, so there's no games. Is it actionable to sell the capacity that's spare there? No, it's not. What's my error margin if I'm saying that 80% of the time there's no one there? Well, my error margin is very, very high, because the rest of the 20% is really, really utilized. So once again, I know that there is no utilization 80% of the time, but it's extremely unactionable because there's no one there to sell it to. Whereas where it is fully utilized, I don't want to sell cheap capacity to anyone because there's no spare capacity available. So that area I need to exclude from my model where I try to sell more. I need to then find areas where it's actionable, where I have people in the area when there is spare capacity available, and the risk of error that I'm selling the wrong thing at the wrong place. So I end up selling free data at whatever these hours, and I happen to sell that at the airport or the train station. I mean, that's obviously really bad. So I need to, but this is where looking at the data in an intelligent way, you can make sure that you exclude these type of things, and it really boils down to that uncertainty in some of these predictions. It's actually not that important because you can exclude the bad places anyway, and the area where you don't want to try to do this optimization.
Yeah, and then I guess
Or
it's
was,
like
yeah.
traditional risk management. You
Yes.
always try to sell something. Well, not always, but for a lot of
Yeah.
services. Not talking about
Yeah.
wireless or telecoms. You
Yeah.
sell something hoping for the best, and it might just not work. I mean, so you
Yeah.
have to kind of accommodate for that. That's why you have SLAs and things like that.
Yes.
You know.
Yes. So what's interesting, and I just want to make sure I add this into the mix, is that I often look at why has telecom industry fundamentally failed in making more money. And when I'm saying that, when I say telecom industry, I'm always talking about telecom operators, because obviously the telecom industry have made a huge amount of money. Look at Apple's and the amount of profit they've been able to extract by selling a premium handset. That money has been explosive. So now the question is going to be, what's happening here, and what's the reason for this? And one of the things is that if I'm a mobile operator, if I offer a service, and I'm saying that I'm offering this service on my network, any operator in the world is always going to be smaller than even a medium-sized OTT. So I'm going to monetize whatever investment I make over a relatively small set of subscribers from a global perspective. And if I'm now successful, I maybe get 10%, 15% uptake. And that's going to be a really, really small set. But if I'm looking at it from a global perspective and I'm offering a access neutral service, which can be used anywhere in the world, getting 10% of the world population is obviously a huge success. So it means that when you're building an app or a service and you're restricting it to just your network, and you as an operator try to make this monetization, it's very difficult to actually attract, call it the smartest talent and the smartest apps, because it's actually pretty stupid to restrict it into one single operator. So that is one of the reasons. The next one is then, why are you not able then to attract these other players to do it in the right way? Well, historically, no operators have been willing to do revenue share with app suppliers, with only one big exception in the past. That was Docomo on the FOMA project. So if you go back to Docomo and FOMA, they actually did revenue share with app providers, and it was actually a thriving ecosystem. And they made a fair bit of money. And the key was that they provided a platform, revenue sharing, and a set of APIs, and the app vendors was then choosing to take the risk. Now you start to look at the Camara APIs and you start to see what's happening here. It's a little bit similar. It's still not a revenue share, but it's a relatively low-cost API for certain services. So net is that you're getting to a point where you're starting to be able to share the risk of building these things, and the operators can start to monetize from a large ecosystem of service vendors that start to use an API. Next place is here then, will they actually start to get to a point where they can do revenue share? If they're willing to do revenue share, which is obviously going to be, a big question, at that point, I believe they will start to actually see some quite uptake in revenue, because they don't have to carry all of the risk, and they will be able to basically utilize a big ecosystem of people who are willing to take risk.
That's
So,
actually a very good point, because the APIs, you don't think of APIs as a revenue share model, but effectively that's what it is. I mean,
yes,
if you think about that way, and it would work because you can just be, it's a many to many. So the app developer
Right.
can work with every operator, and the operator can work with any app provider.
Exactly.
So if
Exactly.
you simplify it, it's easier than a revenue share, because a revenue share is like a one-to-one agreement with each one of them, which is so the
Yes.
API would just generalize it through a
Yes.
marketplace.
Yes.
It will be more
Yes.
efficient, right?
Exactly. So when you look at marketplaces, with being it the Apple or the Android ecosystem, there's well-established economies for that. So the question is, once again, will the operators be in a position to do some of these things? Will they be able to open up? Are they willing to do some of that? We've always obviously seen consolidated billing for, where you can get your Spotify subscription through the operator, or you can get your Netflix through the operator, etc., and it's on a single bill. Those things is, how should I put it, marketing-driven integrations and additions, but they don't use the network in any way. It doesn't benefit from the network, really. It's just a case of that they have a billing connection to the user, and they are able to charge them money and utilizing that. So I'm really looking here at, can we actually add some value? Can we add the network? Can we do something with it? Can we then generate some incremental revenue? And can we then have an ecosystem of app vendors that are willing to take a certain amount of risk? And if they are successful, well, they will make money, the operator will make money, and obviously us helping to enable it will as well benefit from it.
Absolutely. Our time is unfortunately up. We can go on forever, but this has been incredibly interesting, and to think about new ways, about to approach monetization has been great talking to you, Per, again.
Yeah, my pleasure. My pleasure as always.
Thank you so much, and thank you all for listening in, and I hope you found it as interesting as I did. Thank you so much.